So let me show the screen. So the first thing I want to talk about today, for those of you that weren't here a minute ago, I just started explaining kind of what we're going to be going over. I want to look at the advanced rough options. If you were here last week when Al did the webinar, it's going to be not really a continuation of what he did, because I'm kind of continuing on what I had planned from a few weeks ago. If you guys have any questions along the way, make sure to type them in the questions box. I will try and get them answered. If you have anything more specific, there will be a little bit of time at the end of this. If you want to stick around and if you have anything kind of specific that you want to see, let me know in the questions box. There's also a chat box that you can chat into if there's any problems or anything like that. Otherwise, let's get started. So right here is just a very simple part. I don't have much going on with it. It's all 2D, but I use the 3-axis toolpath to cut it. One of the things I've started teaching, and it's actually part of my advanced course, is using 3-axis toolpaths to do a 2-axis part. And really, you can do that as long as you have a solid model. That's the only real rule to the whole thing. So in here, I have a bunch of toolpaths. So I'm going to start off by actually creating a toolpath, and then I'm going to show you guys each individual option for that toolpath. So advanced rough right here, I'm just going to right click on my machine setup 1 and go down to the mill 3-axis. Now, remember, when you pick your geometry, you're always picking the entire part. So I'm going to drag a box over the whole part and then right click and hit OK. Now, I could also set up a boundary, but this part doesn't really need a boundary. I don't want the tool to be locked into anything, especially with these corner cutouts on here. I'd rather let the tool kind of open and leave that area as much as it needs. So I'm not going to set up a boundary for it. So next, right here's our feature page. Clearance planes at 1 inch like the default. 200 thou, 100 thou for the rapid and feed respectively. And then my top of feature is pretty well always going to be a 0 unless I'm showing you guys some stuff on a router, in which case a lot of times those routers go off the bottom of the stock instead of the top. So you'd have a negative, whatever the thickness of your material is there. Next, we then have the machining strategy tab. Now on this strategy tab, I'm just going to look at the advanced rough and we're going to go through it. So next. So the posting tab, the only real important thing for most people on this page is the arc fit button. If you do not click the arc fit button, all of your G code is going to come out as line moves instead of arc moves. There's going to be no arc moves in the program. The good news is if you forget to turn this on, it isn't something that you have to recalculate the toolpath to kick in. So if you forgot to turn it on, just open the feature back up, click this button on and hit finish. It's just really an enabling option for the post processor to output the way with arcs, really. So if you forget to turn it on, just ignore it. If you go in and turn it on, don't compute it, or at least you don't have to compute it. That's the worst thing. A lot of guys get nervous. You sit here computing a toolpath. I had a toolpath the other day that took I don't know, about 30 minutes to calculate. It was a real fine toolpath, real good finish getting put on it. And I didn't want to wait 30 minutes every single time I wanted to make a small change. And that was one of the small changes I had to make, but you don't have to recompute. So just remember that. I'm going to go ahead and turn it on and then hit next. Real quick, the arc fit tolerance, it's set to 0.5 thou. That's a pretty good place to be. The only time you'd really change this is if the arcs were not good enough, if they weren't clean enough when you were creating them. Really, the arc fit tolerance, the way I set it up, is if I go to the parameters page on my 3-axis right here and I have my machining tolerance, if I was to drop this to 1/10, I'd also go back and do the posting tab set to 1/10 as well. Just to keep everything the same. That way I got all the same tolerances on everything. So I'll go next. All right, right here we have our tooling page. And because I have all these other advanced roughs already running, the tool gets picked automatically. So it's a 1/2 inch, just flat end mill. That's what I'm using all the other patterns there. And so you got your 1/2 inch flat end mill, which is fine. Normally it's going to default to a 1/2 inch ball mill. Just be aware. Anytime you get into the 3-axis and you don't put a tool into your tool crib, it's going to make one up. It's just going to make up a 1/2 inch ball almost every time. So you can go in, you define the tool number, feeds and speeds. My feeds and speeds right now are calculated on the fact that this is set to 1018 carbon steel, and my tool is made out of high-speed steel instead of carbide. So I'd have to go in. If I wanted to run off carbide, I'd have to go change my tool to carbide and then repick it so that it updates the material here. Next, we then have our parameter or our patterns page. So the first one we see is the offset pocket out. The offset pocket out is going to start from the inside of the pocket and work its way out. Now, that doesn't mean it's going to start on the inside of the part every time. On a part like this, the pocket out may start and cut these guys on the outside first, but it's always going to start from the outside and work its way into the wall. And when it works on this kind of inside pocket here, it's going to start on the inside and work towards the outside. So I have an example of that right over there. We'll take a look at it in a few. Right here, we have the offset pocket in. Pretty much the same thing, except it works from the outside in. So it's going to start from the outer limits and then work its way through into the part. The next one we have is a morph spiral. Now, the morph spiral is really cool because it doesn't have any sort of linking on it. The links, it doesn't need them. It morphs the tool path so that it doesn't need to link. The tool path naturally just runs into its next cut just based on an angle that's in there. And it's kind of messy looking. It's very tough to see what's going on sometimes when you do use this one. Like I said, I have an example. I'll show it to you. But it's a very good tool path. Then we have one for parallel. I usually don't use this on a part like what I have on the screen here. I'd usually try and use this for something longer, especially if I got some long tubular kind of shape that's going down the middle of a part. I'd like to have this rough those things out. Really, I use the parallel anytime I'm looking for a longer cut. So I want something longer, and the parallel is going to get it. Now, when you're using the parallel, you have the lace angle as well. So the lace angle allows you to change what direction it's going in. 90 degrees is always going to be along the Y. 0 will always be along the X. You can use any angle you want. Just that's how it's going to line up. So if 0 is along the X or the 3 o'clock position, if you did 85, you'd be at 85 degrees between that X0 and the Y90. So, well, not in the middle, but the other option for it is the profile after. So what this is going to do is after it goes and does all of its cutting, it's going to come back and do kind of not a finish pass, but one more little profile to bring it into size and really get rid of all the cusps that are going to be left on the part. So you can picture a round tool just going in and running into this wall is going to leave a whole bunch of just cusp little movements, little sharp points all over. And so the profile after is going to come in, clean up any of those cusps that might be left and have it there. So the next thing we're going to look at is we're going to go with the adaptive roughing. Now, the adaptive roughing is the high-speed machining strategy. What you want to make sure you're doing with this one is just kind of modifying how you're cutting. With most of these advanced roughs, if my norm is at a 1/4 inch depth of cut and a 1/4 inch step over, so really a 50-50 kind of depth of cut step over, with the adaptive roughing, I'm going to go a little heavier on the depth of cut, but a little easier on my step over. So I don't remember what I put in. I'm either doing a 1 inch depth of cut with a 50 thou step over, so a 10% step over, or I might have done a 1/2 inch cut. It's on the other one over there. We'll look at it in a minute. So I'm just going to leave it on the offset out. We're going to zig or zigzag, just depending on how we want to cut. And the zigzag, you'll notice when I turn it on, we lose the climb in conventional milling because it's going to cut one direction and then just turn right around and go back the other way. So not something I really want to do if I want to keep everything moving in the same direction. I want to leave it on zig, and then I can choose whether it's a climb or conventional mill. Next, we then have our parameters. So this is normally where we'd set up our depth of cut and our step over. And for this one, I just say my depth of cut's a 1/4 inch, and the step over is also a 1/4 inch. Remember, this is a roughing pass, so you're just trying to get it to take as much material as possible. So it's whatever your tool can handle is really how you're going to take it. Now, right here is the number of intermediate steps. Now, on a part like this, the intermediate steps are going to do absolutely nothing for us. It doesn't add anything to it. All it does is add more time to this program, and that's only because all the walls on this part are vertical. And so because they're straight, there's no reason to come back and cut them again or multiple times because it's automatic. It's already leaving a nice straight wall. So number of intermediate steps, I'm going to leave at 0. And then the machining tolerance, I'm just going to bring back to 1/2 thou there like it was before. Ignore holes, cut holes is just dependent on the geometry. And it really does depend on the geometry and kind of how everything sits on whether this recognizes there's holes. The problem that you run into with really any time you're working with some of these 3-axis tool paths, especially the finish passes, is when you're using a ball mill. The problem is a ball mill where it gets down to the tip of the ball, it's very small, or it can be read as a very, very, very small diameter at the tip of a ball mill. And so when we see a hole, if the tool can fit, it's going to put it in and make a little cut and then move on. So sometimes, even if you say ignore holes, you'll see a little movement in the top of a hole and then it moves to another area. If that's the case, what you can do is you can put a little surface over the geometry. I'm going to show you guys, I'll show you guys how to do that if you want, but there's a few times that you might actually have to modify the geometry to get the proper cut that you're looking for. I'm going to show you an example of that in a minute what I had to do to get a lollipop cutter to do some undercutting. Was kind of trick it into doing it. So I'll show you that in a few. Right here's the depth options. Really not going to talk too much about this. Our allowance over here, you got global allowance and side and bottom allowance, just like we have in the 3-axis. The allowance here would be how much I want to leave for a finish tool to come clean up. And I'm not really leaving anything, so we'll go next. The leads on this, we can plunge into the part or we can ramp into the part. Now, all of this is all dependent on the fact that this cutter has to be a tool that can plunge. It's got to have a tip on it that can plunge. If you uncheck this button, you'll notice you only have the ability to plunge now. And the reason we do this is now we're going to try and start the tool off of the part. This is important because if you set up a boundary and you didn't give that boundary an area where the tool could plunge off the part, it could potentially screw something up, or it could try and plunge into a part without the right tool. But if we tell it that it is a center cutting tool, then we get our ramp options. So you can do a line, a spiral, a zigzag, or a profile. The automatic option is going to pick one of those 4 ways and cut it. The difference is if I go back one page, is it this page? This one right here. So if we look at this, the way that BobCAD or this tool path is looking at a part like this picture here, you have the right side here with the boss standing up, and then this cutout over here. And it will group that together. So it'll try and do everything on the standing boss and then everything on the sunken in the sunken in pocket there. So when you're talking about your leads, when you put it on automatic, BobCAD's going to pick the best lead for that situation, or at least the best that it thinks. This is not always 100%. You will at some point probably have to come in here, and if it picks a spiral, you'll look at it and go, nah, I'd rather use a line, and you'll come in and pick a line. But by doing automatic, you might get a line entry on, say, the top boss one, the one that's standing, and then a spiral for one that brings you down into the middle of that pocket. And it'll pick that automatically depending on what settings you put in. So right here, I'll just plunge in. With the plunge on any feature, you can do a single depth, you can peck, or you can fast peck. So you just choose what you want and then hit next. The options, not too much am I going to play around with on here. I'm intentionally not using I'm not using the rest roughing because I haven't come in with a larger tool to clean up anything else, but I could if I wanted to, just because some of the corners on this part are a little small. But then right here, we have the machine flatlines. Now, I'm intentionally not using the machine flatlines because I have another flatlands toolpath that I'm going to show you guys right after this. So this is going to leave a lot of material on the part that would normally be taken off by this machine flatlands. So we'll be able to see that. Next, right here, we have our links. So within groups, we can go direct. We can make an S-link or a retract. And between groups, again, direct, S-link, or retract. Gouge checking. Really, with gouge checking, I don't mess with it until I see that there's a problem. When I watch my simulation, if I see a gouge and I see that the easiest way to fix that gouge is to go into the toolpath and pick some geometry to tell it to avoid, then I'll do that. But if I don't have any frame of reference, really, I don't know if this is going to gouge yet until I watch it in the simulation. So I'm not going to set up a gouge check right now, but it is definitely something we can come back and add in later, especially with this toolpath with the ability to do in-process stock. In-process stock allows me to move the tool and kind of account for the tool. Even if it was a shorter tool and can't really reach into the bottom, it's going to cut as much as it can and then move inside the area it cut and cut as much as it can inside that area. So it's going to kind of make some clearance for the holder to get into the part, and then it'll continue cutting, but it's all doing that while it's calculating the toolpath. It's figuring all that stuff out for us. And I do not want that on. Okay. The last page here is the advanced feed rate. So you have your general overrides, which let you convert your rapids to feeds. So that's just going to make no G00s output inside your code. You're going to get G01s for everything. And then you'll set the feed rate that you want to output every time you do a rapid. Right down here, we have our blend spline links. This is just how we can link our toolpath, our links together, just with a spline to make it a smoother, better transition. And then right down here, our feed rates, we could do standard or we could do volume based. And that's all based on how much engagement that tool actually has. It'll speed up and slow down the tool as it's cutting. And then I'll go ahead and just say compute. And we normally have to, well, we're going to sit through this just to see what it gives us. But it should be a pretty standard one. And then over on the left there, inside the cam tree, I have a whole bunch of toolpaths. So let me blank this out. Now, I'm not going to run through the simulation. If anyone wants a copy of this part, let me know. I'll send it to you. You guys are free to have a copy of this thing. It's a part I made up just for fun one day. But it shows off, all these will show off each pattern that could be done with the advanced rough. And so here it is. So the offset out and the offset in are kind of tough to see the difference between, because there's an offset out. So this one's going to try and start in the center and work its way out from there. And if I right click on the advanced rough here, I can actually say back plot, and I can rotate this around and say show my tool, and then hit play. And I can see, okay, so it's starting on the outside of the part here. So that's the offset out. And let me turn that speed up quite a bit. There we go. Now we can see what's happening. So it's going and making its cut, and it's going to do the whole thing as much as it can all the way down the part, and then it'll move to another location. So I'm going to go ahead and close out of that. So that's just a standard offset pocket out. But you'll notice, since I didn't turn on the machine flatlands, we didn't get a nice cleanup toolpath here all the way around. Decent looking there, and I'm sure these will be fine. But that's only if the toolpath naturally ends right at that point. So you'll see right there, there's no toolpath on that ledge. So this toolpath, this is where it's going to be cut to, up to this point right here. So we do have some material still to clean up. The offset pocket in looks really similar, but it's all about which direction the tool is moving in when it's cutting in now. Not that it's a climber or conventional, but whether it's starting on the inside or the outside of the part. So if I right click on this and say back plot, I can go turn my speed up a bit, and then I'll turn my tool shaded and then hit play, and we'll see this one's starting on the outside. It's doing a full cut all the way across that part, and then it's going to work from there in. There we go. The next one's the morph spiral. I mentioned it. It's tough to see what's going on with this toolpath, but it's a very cool toolpath. So if I look straight down on it, we can probably see it best. But here is the spiral, not the spiral that we see down here. That's in the bottom of this hole here, but it's just at the top. So let me go back to the top. Here is that spiral. So it's converting that kind of weird shape that we got to be able to match, this rectangle, but also that open area. So it's able to work its way there. If I right click and say back plot on this one, we can see it's going to run this. Let me go ahead and just fast forward till here. There we go. So I'll go right in here and then hit play and speed it up a bit. And now it's going to start that spiral. So you can see that kind of diamond shape it's making off the start. And then it's slowly morphing from that inside shape that we just made. And it's going to slowly morph so that it eventually matches that rectangle in the corners. But it's going to do it as an open chain after it gets rid of most of the inside geometry. That's the step we're on now. This would be all gone. So now it's just going in and climb milling those edges to kind of widen out this entire thing now. The next one we have is the parallel one. Now, this isn't one that I use very often, especially in a case like this. It'd be a huge waste of time. And so I usually use this for a longer open-sided part. Now, this isn't bad for the inside here, but not for the whole part, and maybe go along the X might be a little better. I don't know. I wouldn't use this function for this exact kind of part. But if this part was open on the ends, or if you ever go into the getting started when it opens up. So if I go to help here and I click getting started, this part down here is a really nice one for that kind of roughing method because it's such a long part to cut. So you can get to that just by going to this getting started. You click on the 3-axis pro and then you click on the picture. And when you click on the picture, it'll load the information. So how to draw it, how to machine it, how to simulate it, and how to post it. You'll get a written tutorial for every one of those, as well as down at the bottom. So you have a CAD, CAM, simulation, posting. So they all the buttons actually do certain things too. So if I click CAD, it hides all the toolpath, lets me see the CAD tree. And so for a part like this, where it's got this long open-ended portions to it, that's a really nice one for that parallel style pattern. But if it's a part like mine where it's closed off, I'd prefer not to use that toolpath, but just depends on what you can get away with. And then the last one, I'll go ahead and move that up, is the adaptive function. So it looks like I just did I think I went 1 inch deep. So it goes 1 inch deep, then it starts its cut. Now the big thing with this is I'm all right with it taking a very aggressive, heavy depth of cut like that. What I'm not okay with would be if I left my normal, 50% step over. It's just way too aggressive on the tool, and I'd rather have this tool come in and just shave it, but I'll be moving real fast, and I'll be at a much lower depth. So what normally takes me 4 passes to get down to that depth is not going to take me 1 to that depth, but a lot more step overs. So you can kind of determine which one you want. I like this method a lot because it's going to let my tool wear a lot more evenly. I'm not burning out just the bottom 1/4 inch of my tool. I'm burning out the entire length of the tool across the whole thing. So this is a really good option to save tooling, to make sure you don't do any really weird, just weird movements all around. It's a really pretty safe tool path, and you can see it's going around doing all its cuts. Now, again, I didn't turn on the machine flatlands option, and that's the reason we're not cutting a lot of these floors, and that's because I already did a part that has the flatlands on it. So let me open the flatlands part real fast. Now, I'm going to go through this one a little bit quicker than we went through the last one, and it's only because the flatlands is pretty much a dumber version of the advanced rough. It's got a lot of the same options in it, but it doesn't have as many options. I don't mean by dumber in any way. It's still a very, very good tool path. It just doesn't have as many settings because it really is a specialty tool path. It does one thing, and that's cut flat things. But that one thing that it does really, really well, and it'll recognize it without you having to tell it. I think flatlands and the pencil mill are two of the best ones of. I don't really have to think when I'm using them other than maybe a step over amount and what tool I'm using. The flatlands will find the flat areas. The pencil mill will match the tool to the radius on the part. I can't ask for anything more. So we'll go with the flatlands and hit next. Posting, again, always turn on arc fit unless your machine can't handle 3D arc moves, because this will output 3D arc moves. Right here, we then have our roughing tool. So I'm going to use a 1/4 inch on this one, and primarily because I took some measurements, and this radius here, the smaller of these 2 radiuses on here, that's a 1/8 inch radius. So I have to use a 1/4 inch tool. So not a big deal. It's just a lot more than I'd want to do. So same kind of thing with the patterns as the advanced rough, because the flatlands really, it's kind of part of the advanced rough. It's the reason we have the flatlands toolpath. So you got the offset out, starts on the inside, works its way out, the offset in, the morph spiral, the parallel, and the adaptive roughing. Right, here's our parameters. So I would always try and go with like a 50% step over if I can, if the tool can handle that. In this case, I will. Flatlands, so you have 2 options for your size of the flatland. So right here, we can see the minimum width of flatland. So the smallest area that's flat that BobCAD will recognize and waste its time cutting is 50 thousandths. So if it's anything, if you have a small ledge on the part that's smaller than 50 thousandths, BobCAD's going to ignore it. Now, if you have an area where you have a large flat area, and say like in this case, I'm using a 1/4 inch flat end mill. If I have a large flat area, the best idea would be to go in there with a much bigger tool and clear that out a lot faster. So what we have here is a maximum width of flatlands. We could tell it if there's any flatlands that are wider than this, in this case 5 inches, it's just not going to cut them. It's going to ignore them. And that's for you to be able to go back, change to a bigger tool. If you want to go to a 1/2 inch, or if you had an area that was over 5 inches, you could switch to a 3/4 or 1 inch tool and really go hog that kind of material out. Otherwise, if you just leave it unchecked, there is no maximum width of flatland. So it's not even changing the settings. It's going to put it in. If it's a flat area on the part, it's going to get a cut. The machining tolerance, again, set to 1/2 thou. I don't really mess with that too much. Unless I see my tool path and the finish just doesn't look good enough, I might change that, but usually not. This is a finish pass, so I'll leave the allowance at 0. The leads, I'm just going to say plunge, just because it's just one added thing. The options, there's really not too much to this, just the links, the gouge check, and then the advanced feed rates. When I'm all done, I can hit compute, but in this case, I've already done all these tool paths. So here's the offset out. So it's going to start from the outside, the inside of every one of these pockets and work its way out. The offset pocket in is going to work its way from the inside. Whoops. That's not the right one. Give me a second. Let me edit this. That's a pocket in. All right. Finished. Did I forget to recalculate it? Let's give that a compute because that looks more like a parallel pattern to me. And I may have had a parallel pattern on here before. I might not have recomputed. We'll find out right now. I put this together just before the whole thing. Yeah, something weird about that. I definitely don't like it. Talk to my development guys about that. That definitely looks like a parallel pattern to me. So let me do this. Rename. I'm just going to put a little note here for myself. Give me 1 sec. Check this. All right, there we go. So that's the that should be the offset out. Here's the flatlands. This should be a morph spiral. I think there's something wrong with this part. That's what I got going on. I'll figure it out. So normally the morph spiral, the parallel, the adaptive, they should all look the same as these, but only on the one level they're working on. So like I said, I'll give you guys an update on this part. Show you some of these toolpaths after I get it working again next week or something. I don't know. I know I copied a parallel toolpath, but the flatlands is working for the adaptive. That's the adaptive flatlands. The only problem with the adaptive is in some of these areas like here, depending on your step over and everything, you sometimes end up with a lot more toolpath than you might really need. Like the offset out doesn't have 20 cuts down the middle of this like the flatlands down here for the adaptive, but you can definitely play with some of the options, tweak things, especially the step over amount. That's always going to make a huge difference. And yeah, like I said, I'll fix these other ones and show you guys a sample of it next week just so we don't waste some time on it. All right, now on to the good stuff. This is something I was playing around with, and I don't get to use this toolpath very often where I get to do undercuts. So I'm going to talk about the advanced Z-level finish. Let me just save this and get it out of my way real fast. So the advanced Z-level finish, I'll save that and get it out of my way. 2 seconds. All right. So I have a roughing toolpath on here, and all it's doing is going in and just taking the material down. And so inside the advanced Z-level finish, oh, and by the way, I just want to show you guys this in case you didn't realize it for version 31. You no longer have to right-click on the feature 3 axis to get back into the feature. You can now right-click on the operation you want to view and say edit, and it'll open you up to the tooling page for that feature. Really cool function. It's something that a lot of guys haven't noticed yet because I think most of us got used to never being able to do that. I still usually go to the feature, but just so you guys know, you can right-click on the feature or you can right-click on the actual toolpath for the feature and then just say edit, and it'll bring you right back into that page. So cool. Have a good one, Richard, if you're taking off. There we go. So right here we have the tool information, just what size tool we're using, and the in this case, it's a ball mill. So 1/2-inch ball. The rough was already done with a flat mill. So right here, the patterns, there's really nothing new on most of these pages. You're going from the top down, the bottom up, however you want to cut. On the parameters page, you have the depth of cut set here. So I got mine set to 20 thousandths. The machine flatlands, this is going to go in and it's going to match the final cut. So one final pass is going to cut all the way to the floor level so you can blend that floor and wall together. The big thing with that is a lot of times it's all about the ball mill you're using when you're trying to blend it. If you go too big, the radius that's in there it's just too big left in the corner. And if you go too small, well, there's really no too small. If you go too small, you just can't cut as much. So you take more time. So machine flatlands is a good one for just getting a final good cut where it's just going to match the floor depth and then make it a little easier, hopefully, for you to blend into that floor. Machine vertical walls only cuts the vertical walls. If there's any sort of taper or curve to the wall, this toolpath is going to ignore it now. And then we have the adaptive depth of cut. So if this is our normal depth of cut, the areas where we're going to get a bad finish is where the toolpath kind of flattens out, where it's not as vertical. This is the Z-level toolpaths, any of them, the Z-level rough, the Z-level finish, and then the advanced Z-level finish. They're very good at one thing, and it's cutting walls. The steeper the wall, the better. Now, with the advanced Z-level, you can go past 90 degrees with the vertical on your wall. You can go past 90 and do some undercutting. But with the normal toolpaths, you won't be able to go past 90. 90 degrees is normally the stopping point, because after 90 degrees, your end mill is useless. It can't cut anything else. So this one I will show you an example of an undercut here in 1 second. So the adaptive depth of cut basically lets me go in and add extra passes where BobCAD sees that it needs extra passes. So normally you would set up your depth of cut. My depth of cut's 20 thousandths. And so if there's areas on this part where I think I could finish it better with a finer depth of cut, I can go in and do a minimum depth step. So what's the minimum depth of cut? And I could say I want to do 5 thousandths. So I'm not going to compute this because that'll take a lot longer to calculate. But basically, it's going to go in and find the areas where a 5 thou step over could, or a 5 thou depth of cut could give them a much better finish. And it's going to add all the toolpath it needs right there. Again, within the 5 thou range. It's the same thing you run into when you're running 20 thou. It's got to go a distance, so it's a depth. So if this is 0, the first pass doesn't happen until 20 thousandths. Then 40, 60, 80, 100. When we get down into here, we have to start breaking it up because of this angle, because the distance from here depth-wise in the Z is still 20 thousandths between every one of them, but the kind of spread, the full pull that it has to get all the way around that area is going to be, we want it to be a bit tighter. So you can go in and give it a better depth step as well as a step over, because the Z-level finish and the advanced Z-level finish, they normally don't have a step over amount as well. And that's a big one because sometimes you start working on these flatter areas. You need a few more passes and you're able to come in and say, okay, if you don't hit your depth, so this is all about if it doesn't hit its depth. So if BobCAD sees that it cannot make its next cut at either the 5 thou level or the 20 thou level, and for it to hit that distance, it would have to go further than, in this case, say 100 thousandths to make that pass. The maximum step over is going to kick in before then. If we said put it at 50 thou, the tool is only going to travel at furthest 50 thou in, let's say, X or Y, but not Z, and that's where it's going to start its next pass. I'm not going to do any of that fancy stuff. We got our top and bottom of job, our allowance, our leads, our options. Now, not too much going on the options here. The angle range still lets you lock angles in. Undercut, we're going to look at that there in 1 minute. But when we go down here, we then have our links. So this is how we connect our pretty much each pass together. You got follow, direct, horizontal, vertical. You can do a spiral, an S-link, or a full retract. Now I'm going to leave it on follow and then hit next. Here's our gouge check. Again, I don't set up the gouge check until I know I need it. And then our advanced feed rates. So I'm going to hit finish because I've already done this toolpath. And if we look right here, we can see there is all our passes, all the green that we see. And so right here is where we're going to start getting a worse finish. You can see how nice and close the toolpath is here. But as we work our way up, it starts to spread more. And that can give us a bad finish right there. Now you can also see where we're linking. So how we're connecting one path to another. One of the new things that we added the ability to do is on the links tab, you can set your linking position. So I'm going to start by not shifting anything. I want to leave that at 0. Or actually, I'll start with the shift. So the shift changes it. So normally, if you leave it at 0, you're going to get the finish like we have. Starting from the center, goes at one point, it goes straight down all the way. So what we're allowed to do now is shift any subsequent passes. So if I say shift them all, shift each start by 1/8 inch, and I hit compute, we're going to see after this thing calculates, the links are going to be a lot different. So we'll give it a second to calculate. Like I said, in the meantime, if we're waiting on calculations, if you guys have any questions, just type them up in the box and hopefully get you an answer for them. So there should be a questions box. There's also a chat box. Whichever one you want, I got them both on my screen. I can see either one. So give it a bit longer to calculate. Now, the calculation, just so you guys are aware, all of this is being done with the processor inside my computer. Having a good graphics card doesn't really help the calculation of a toolpath. Really, it's the processor. The RAM's going to be more for your rapid access, but it's if you have a nice processor, you can see the difference between someone who's got a good processor and someone who doesn't have someone who has a bad processor. The timing calculation's way different. So here's the toolpath now. So that's where it starts. And then instead of connecting straight over, after every pass, It's going to lift the tool, rapid to where the next pass is an 1/8 inch away, and then it's going to connect those all with a rapid. So it looks nice. The only problem with this that I don't like is there's a lot more rapids happening. The tool lifts up after every cut, moves to its next position, plunges down, makes its cut. And then, so there's a lot more rapids in here than I might want. So I'm going to go back in here and say edit. And then just go back to the links tab. Now I'm going to set this back to 0. The other option we have is the start location. The start location is pretty cool because I can actually come in and pick and say, I want to use this back corner here as not really a start point. It's not a plunge point, but it's going to line up. So right now my start points are starting, they're starting here and they're coming down this way on the part. If I'm leaving just a normal one, if I do it the other way, it's going to go down this way. So if I hit OK and then I hit compute, we'll see that the linking is actually going to move from this side to the other side. So I'll hit compute. And while that's computing, I can answer your question, Ron. Why would you not use a spiral cut? The problem with the spiral cut in the advanced Z-level finish, the advanced Z-level does have a spiral option. You still run into the same problem the Z-level runs into all the time anyway. The depth of cut is what's the deciding factor, not the step over. So if it can't hit the step, it's going to kind of fall off the side a little bit. I'll show you an example of it. There is the link now. So you can see just by picking the start point, I'm able to get it to start and chain down this way instead of down the other side. That's the only difference. So let me show you real fast, Ron, how this one's going to work. Now, I have a pretty fine step over on this. Let me start by just dropping this or bringing this up to 50 thou. It'll calculate a little bit quicker, and it'll show us it'll exaggerate the bad parts of this a little bit more. So I'm going to go ahead and click spiral. Now, this toolpath does a fine job on a spiral when it's cutting on very steep geometry. But when it doesn't have steep geometry to cut anymore, so when we get to the top of this, or when we're working on the top of this and it's kind of flatter, it's going to give us a worse finish. So we'll do that. We'll go from the top down. And then let me just set my links. Don't need any special linking or anything like that. So I'll go ahead and just say compute. And so if you're going to use, if you have access to the Pro toolpaths and you want to do a spiral toolpath, use the equidistant. The equidistant is going to give you one of the most beautiful spirals you've seen. The only downfall to it is no arc moves. So it definitely is. There's really not a good or bad way of doing it that's going to be consistent. In that case, it comes down to how much room does your machine got. If it can fit all of it, then you're fine. But if it can't, there it is. So you can see now what we're looking for is a nice tight step over like we have right here. That's going to leave us with the good finish. Up at the top, though, where it starts to spread even more and more, I'll go ahead and launch the simulation. We'll take a look at it just because it's just not a good enough finish is really what it turns into. So let this thing launch, and I'll just fast forward. I got something else I want to show you guys in the simulation. I'm working on, I wanted to show you guys some fixturing and stuff inside the simulation. But I'm working on the parts for that, so I'm going to do that in one of these upcoming weeks. I'm trying to make it look cool. That's the problem. So if you look at my simulation, I got this 3 different views going on right now. And the way you can do this is on the View tab. If I say maximize, it gives me just the single view like we're all used to. But I could say, show me 4 different views of this. So we can see right here, I'm seeing an isometric view. This is the top, front, right. So these 2 are the same kind of isometric view. Looks like this one's just zoomed out a little bit more. Yeah, just zoomed out a little bit more. This is a top view and this is a top view. But each of these are individual to each other. So I can actually rotate this around like so. And I can see each, I don't know, give me a different view. There's nothing to see on the bottom, so I don't really need to see much. So I can see each one of these. Now I'm going to fast forward right through to Op 2. What's cool is these are all the same window. They're just different views of the same window. So I can click right here. It's going to fast forward. It'll take a second. It's going to fast forward through what the advanced rough should have done. And then what we're going to see in all 4 windows is the updated part. So when we hit play, we can see what that spiral is going to do. So you have 3 views you can show. You can show 4 views. You can do 2 rows. You can do 2 columns, and you can reset the whole thing. So right here, you can see there it is. Whoops. And then I could go ahead and hit play. And so you're going to see all the tools moving. I can't imagine this being very easy on your computer to run. So if you do have any sort of graphics issues when you get into the simulation as it is, This is probably not the best thing to do, just because now you're running 4 parts, and it's each window has its own settings, because you can see these ones, the tool is moving, but on this one, the part's moving. So you can go in and actually check the simulation, and you'll see right here, when I click on this, the workpiece stock option is set. But if I click on this one, the tool is set. So I rotated it too. Let me zoom out there. Whoops, fit. There we go. So if I want to change that, all I do is just go tool, workpiece stock. That's going to lock it in. And then now they're all locked. So you can have each individual window, and they can have different settings for each window. When you want to bring it back to one, we can go back up to view and just say maximize. And there we go right there. So this is what I was talking about, Ron. Right here is the bad finish. And if you make that step over any larger, it's going to exaggerate it even more. The Z level really likes to cut steep walls. The equidistant, though, would have 0 issues cutting that one, and you'd set it up pretty much the same way. You go through it when you get to the patterns page. I'm not going to do it right now, but if you get to the patterns page of the equidistant, it will also have a spiral option. So right here, I'll go patterns, and there's the spiral option. But the difference between this one and the advanced Z level is the equidistant is going to keep a very consistent step over across the part. And that's partially why we can't do arcs with it, because it's a point-to-point toolpath. Everything about it's point-to-point. So there we go. All right, so that's the advanced Z-level finish, just a quick part of it. And then I want to show you guys let me just go back here real fast, and I shouldn't need to save that. No. I want to show you guys the other one. So open this and undercut. Okay, so very, very simple part that I have on the screen right now. I can actually turn off one of my layers that has some stuff that I don't want on it. So I'll turn this off. And so what you'll see is this is the part. All right, and from a top view, looks like just a pocket through a part. The thing is, it's only one, or technically 3 sides of this part that need this. So what I did was when I drew this out, let me hit this one, I tapered, I don't want to go that way, hold on, front, side. There we go. So I tapered one wall, and that taper kind of wraps around. So it's really about halfway up this. Well, you're going to get a taper for kind of a bunch of this stuff. A lot of this is tapered. So I drew this. There was no fast way to do this. I went in and surfaced a solid of this, and then I cut it. I subtracted it from a cube or another piece of material. The problem that I ran into, and I'm going to show it to you guys, is with this part here. So if I remove my old geometry and say reselect, again, I pick the whole part, I hit OK. Now with this toolpath, so let me go in, I'm going to recreate it as well. The problem that I run into is the depth of the part. The part's 1 inch thick. I need the tool, though, to go past the bottom of the part a little bit to clean up the walls perfectly. So when I go in here, I go into my mill 3 axis, pick my geometry, I pick the whole part, and I hit OK. Then I go next. So the feature, all this stuff's pretty standard. I'm going to use the advanced Z-level finish. I already have roughing pass. The advanced rough is doing the straight wall, so it's finishing the straight wall, and it's doing a rough and a finish pass on that portion. But a vertical, a standard end mill cannot cut an undercut. So for this one, I have to go through, turn on the arc fit, and get to the roughing page. Now I can go up to my tool crib. Now inside the tool crib, over on the left here, we can see all the available tools that we can use with this toolpath. And so I'm able to use tapered tools, T-cutters, dove mills, and lollipops. I want to use a lollipop, and I already have one in here. It's a 1/2 inch lollipop with the shaft diameter of a 1/4 inch. So I have an 1/8 inch overhang on either side. So I'm going to go ahead and pick that lollipop and hit OK, and then hit next. Now right here, the patterns. I can go from the top down, the bottom up, zig, zigzag, or spiral. I'm going to go from the top down. My depth of cut, for a nice finish on a lot of stuff, I'm going to go 20 thou. If it's not good enough when I watch the simulation, I could definitely go more than that or less than that, depending on what I need. Next, I then have my leads. Nothing to change there. Options. All right, now when we get to the options with this toolpath, the part that's needing to be cut is the undercuts, and that's the only thing that actually needs to be cut. If you come in over here and you just click undercut, it's going to use this this lollipop to try and cut the whole part, but you're also saying, you know what, as you're cutting the part, go ahead and do the undercuts at the same time. I'm not trying to machine a full part with a lollipop because I'm not trying to spend that much time or that much money on a bunch of lollipops. So I can come in now and say machine only the undercuts, and it's only going to give me a tool path where it recognizes that there's any sort of overhang. And so I'll go ahead and hit next again. The links, not messing with anything there, gouge check, nothing. So when I'm done, I'm just going to cancel out because I already have this calculated once. And so right here, or actually I need to recalculate it. So let me compute that. So right here, I have a tool path getting calculated. It does take a little bit of time to calculate these ones because it does have it's doing an undercut. I mean, it takes some time. It shouldn't be too outrageous. Again, if it seems like your tool paths are taking way too long to calculate, the best thing to look into is your processor. Just because your processor is going to be the biggest thing that's doing all the work when it comes to these calculations. So definitely something, if you don't have a good one, that's probably one of the biggest things to get an upgrade for. Graphics card's big as well. I don't want to make it sound like that's not important. The graphics card's huge as well. But if you're taking a long time to calculate even simpler tool paths, then you're going to want to get probably a better processor. So should be getting close to the end here eventually. So, whoop, sorry guys, I hit my microphone. All right, come on now. The nice thing about the undercut feature is I didn't have to tell BobCAD what to cut. It just did it. It recognizes the area that needs it, and it cuts it. There is problems with this toolpath, though, where it doesn't cut as deep as we might like it to. But I will show you a way to fix that. It takes some work, and if anyone's interested in more of this kind of work, let me know, because I hate doing it, but I love showing you guys how to do it, because it's a lot of custom surfacing that might need to get done. So right there's the cut that's getting made now. And so it's just going to go in and cut. So I'm going to go ahead and launch my simulation. Let me do this first. If you ever want your simulation to load faster, if you want it to load faster, you turn off the solid, and it'll bring in it'll pull everything in faster. In this case, I don't want to turn it. I can turn it off. This will be fine. So this will launch the simulation a little bit quicker, because when you have a solid model on inside your CAD window, it unlocks the ability to show a workpiece under the visibility tab here. And without a solid model on inside the CAD window, you don't get a workpiece. So if you leave it off, no workpiece, which means we don't have to try and pull a copy of your model into the simulation to make a workpiece. So it loads a little bit quicker for you. And I'm going to fast forward. The advanced rough goes in. Like I said, all that's really doing is machining the flats on the part, and it's going to give us these corners. The thing is, I put it to a zero allowance. So it's machining everything that it can to size. And then I'm going to just flip this around. If I can get it. Come on now. There we go. There's a good view of it. So now get that side in there a little bit. There we go. So I'll go ahead and hit run. And so the tool is going to cut its way in, and it's just going to slowly start putting that taper on. Now, I think I have it about, I think this is about 20 thousandths for the depth of cut, and it's a decent finish. The problem that we run into with it is, as we start to get closer to the bottom, the tip of the tool, when it hits either, let's call it the bottom of the stock or the bottom of the part, it stops cutting. It's kind of done at that point. And so that's what we're going to see here in a second. When the tip of that tool gets down all the way down to the bottom, it's going to stop its calculation and leave us with a real ugly ledge. And there it is. So you can try and play around with this. There's a few things that you might be able to get away with. Possibly making the stock a little bit thicker would allow it to go a little further. The problem is, since the geometry ends, I'm more inclined to think that it can't construct the geometry that's needed to keep moving it down. But the thickening of the stock is definitely something I could try. I haven't yet. Like I said, I just started playing around with this earlier today with this part, but I've never had this issue before. So with the problem that I got, it's leaving me that huge cusp on the bottom, and I can't have that. And I don't feel like flipping the part over and machining it again. So what I did was I went from, here's my normal model. All right. I went and, like I said, I constructed all this geometry. So on the CAD layer, I made this as a 2D part. My problem was when I initially made it, I didn't make it tall enough. What I should have done was made the bottom a little bit longer. And so that's what I did. I went in and did these second surfaces area, this other layer, and I pretty much reconstructed the whole thing, but I made it a 1/4 inch longer on each leg. The only hard thing was calculating out this radius here. And it's not perfect, but it works for what I got, because it's a 1/4 inch radius up here. And then as I taper down, it's got to get a little bit wider. So all around kind of a funky part, but it didn't cause too many issues. I got everything joined up, and that left me with layers or surfaces that look like this. So they start at the same point, but they go a 1/4 inch lower down at the bottom. So what I do with this is I turn on all my solid models now. So just like this. And then I right click on the geometry and I'll say, let's remove the old stuff. And then I'll reselect the new, and I pick everything together. And then I go ahead and hit OK. Now I can compute my toolpath, and it's going to allow that tool to go lower because it sees the geometry and it can reference off of that geometry down that. Yeah, Kenneth, you're running into the same thing. The bottom of job doesn't really, from what I've seen, that's what I'm trying to figure out here. The extra stock is where I'm thinking you might be able to get it to go further without doing all this work. I haven't tried it yet because the thought just popped into my head a minute ago, honestly, while we were doing this. So I'm going to try it as soon as we get off this webinar. But that could do it. But you still run into the fact that you're using a lollipop that without that geometry being extended, it might not offset properly. It might go, even if you could get it to go past the bottom of the part, it might drop and consider that wall to turn kind of straight, which I guess wouldn't be the worst thing in the world is if it went straight after it got past the bottom corner. But yeah, and if you're using it, so you shouldn't have a problem with that with the ball mill. If that's the case, sometimes I've had issues with the bottom of job where you do have to make the stock a little thicker. But if there's a case where you're not getting the part to cut all the way through, send the boys in tech support an email or give them a call just so they can look at it and see why it's not forcing its way through. Because technically, that bottom of job option that's inside this feature is kind of the trump card we get to play. That should be the one that everything listens to, but that's not always the case. Because if you give it the ability to, if you tell BobCAD that it's okay to do something, if you tell us it's all right to go, deeper and lower into your part, usually it does. But yeah, cases like this one, and I'm thinking this is because it's a weird specialty cutter, but cases like this one, they definitely give you some weird stuff. So yeah, like I said, shoot me it as an email if you run into those parts, and we can take a look at them. Really, any of that stuff for any of you guys that are still listening here. If you have any parts that you struggle with and you don't mind, I mean, if you don't care to see them or everyone else to see them during one of these webinars, you can feel free to send me your parts and we can try and work through some of the issues, because whatever issue you're having, there's a very good chance someone else is probably having it or had it before that might know the answer. Or I got tech support here, so we could probably figure it out. So give this a little longer. I'm not sure. There it is, finally. So now, again, turning everything off for the solids, it just makes it so it loads faster. 2D geometry doesn't mean anything when you're launching the simulation. All we're bringing in is solid models. So, excuse me. Right here, fast forward right to the advanced Z level. And then I'll fast forward through this a little bit as well, just so we don't have to sit through the whole thing. Just get right down to, I'll go about 3/4 of the way down, see where we're at, and then hit play and run it. Now, I did have to put leads in for this. I had to use, I believe I'm using a circular or right angle lead, because if I didn't use a lead, it would try and plunge down right next to this wall and send it down. Ken, you could send any parts to support@bobcad.com, and just in the subject, just say this is for Mike for the webinar, and it'll all get to me. So right there, you got your now undercut part without having to flip it over. So we got this job done in a one-op kind of part. There it is. So hopefully some of you guys will. This is pretty advanced doing lollipop cutting and all this kind of stuff, but definitely some very, very cool functions that you can get into with it. So being able to do undercuts is a big deal. So that's pretty much all I got. We got a couple minutes left. I don't want to start jumping into the NC editor. If anyone's interested, the NC editor, you just post your code. And if you have an issue with the NC editor not launching, I just heard about this today talking to the tech guys, or at least not launching the first time. So you right click in here and you say NC editor. It may launch on my other monitor. So give me 1 second. It likes to jump around on my screens here. All right, hold on. Whoops, I didn't hit it. There we go. So if you get an error that tells you that your NC editor is not launching, it'll pop up. It'll have this initializing box pop up. Mine's still loading. Give me 1 second. I don't have the best processor in the world, so if you got a better one than me, you're probably doing pretty good. It's not bad, but it's really not the best. So let me move this over here. There we go. So the NC editor opens up. If you get a problem where when you launch the NC editor, normally a big box pops up and it says initializing on it. And sometimes it'll just sit there for a minute. It's all you got to do is click the X on the corner of it to close it. And then a little error is going to pop up and say no license found or something like that. Just relaunch it right after that from the same CAD, from your same code box over there, and it'll launch with no problems. It's a fix. They're going to have it fixed coming up in one of the newest builds, whenever it comes out. I don't know when it'll be fixed, but for now, just so you guys can get around that'll help you out a bit. So in the NC editor, it's pretty much, it's got a lot of the same settings that the Predator used to have. The difference is most of them are free, which is a big deal. There is still 2 levels of the editor, but it's got some things for editing codes. You can replace your geometry, or you can replace your code just by going in here. Hold on, it keeps popping up on my other monitor because I don't have it set up right. So right here, you can say I want to find whatever, and I want to replace it with whatever, and yeah, right there. You can also say I want to go to a specific line. You can resequence your line numbers. So if you've made a change, you need to resequence, you can do that. You can remove any blank lines. So if your machine doesn't like having blank lines in it, you just get rid of them. And then spaces, if your machine really hates spaces, you could say remove spaces. These are all kind of options, though. I mean, resequencing line numbers, that's a big deal. Some machines won't go out of order. But the remove blank lines and remove spaces are something you should never have to do that in here unless you're trying out a post for the first time, or unless you wrote that code by hand and you put spaces in it. But blank lines and spaces are things that we can handle inside the post processor. And if you don't want them, let us know and we can turn them off. You can also change the feed rate, which is kind of cool. You can go in and do a certain unit. You can say, I want to do imperial. I want to go, let's go 200% the feed rate. So I'll go right there. And I can say, do that to the whole file and just hit OK. And so we'll see right there, we're at 13.3476. I didn't look at it before, so let's go ahead and hit OK again, and it's going to double that now to 26. So you can actually change your feed rates right there, and yeah, there we go. Close that off. Spindle speed, same thing. You can go in and tell it what spindle speed you want to go up. It'll find anything with the S for the spindle. Where is it? S595 here. It'd be able to go in and say, let's go 200% or whatever I end up with. Oh, man, that was good. Do the whole file and then hit OK. And there we go. We just doubled that size. So you can change it right on the fly in there. And then edit values lets you go in and change actual D values, H values, or you can just type into the code. If you knew what your spindle RPM was supposed to be, you can just type it in as well. The other page right here, we got view. This is going to let us collapse and expand these kind of breaks for tools. So it'll separate each tool anytime it sees a T1 or a tool call out. It might be the M6 it's looking for. It puts these little collapse and expand options on here, so you can collapse and expand those areas and see the code in between. Next is just going to take you from one tool to the next and kind of find the tools. Next, also finding any comments for you. So if you're looking for comments, if you've left comments, and then you can also say you want to compare. Now, compare is going to let you open up another NC file. In this case, mine's not the same, even close with this comparable part, and it's going to build up it's kind of building a comparison between the two. This might not be a good idea, but there we go. So you can see that there's nothing the same between these two pieces of code. So not something that I'm really going to be doing. But if you had two pieces of code, you were trying to find out what was the difference between the two, you can compare them and run it that way. I don't know how to close that one though. All right, whatever. Oh wait, there we go. That's the one I want. Whatever. So the last one is the simulate options. Let me close this real fast and just reopen this NC editor. And this will let you actually go through and simulate the part. That's the initializing thing you should see every time. If it doesn't disappear, hit the little X that was in the corner, and then it'll close down. And if you're unlucky like me, it'll pop up on the wrong screen every single time. Now, with this whole thing, you do need to make sure the machine and everything's set up properly, especially if you're going to try and use a DNC transfer. If you're still transferring to your machine with an RS-232, shoot me an email. I'll get you guys set up with, if you want it, if you're interested. I have a customer of, or not really a customer of ours, but he's there's a guy out there. His name's Jerry. He makes a product called the ShopLink Flash. If you're still using an RS-232, this gets rid of the RS-232. It basically makes a little box that mounts on your machine that talks like an RS-232, but it converts it to a flash drive. And it's one of my favorite, one of my favorite things that they make. He's even working on a wireless option. I haven't talked to him in a little while. From what I heard, he had it working for a couple hundred feet, so a wireless transfer. And I know he was trying to go bigger with how far he could transfer. So if you're interested, you can either get in touch with me or or you can do a Google search. It's just ShopLink Flash, and yeah, he sells them. They're something that just mount on your machine. If you're trying to talk communications directly with your machine, you'll have to do the COM port setup beforehand. Regardless of if you're using a RS-232 port, there's going to be some sort of COM port setup. The problem with doing it through your computer is you got to set it up in more than one place. The good thing about doing it through your computer is you only should have to set it up once. So you're going to have to set it up inside your control panel. So I'm going to open up my control panel and then open up the device manager here and then close the control panel. And so, come on now. Oh, I opened it twice. Hold on one second. All right, so here's my device manager, and this is pretty normal for what a device manager should look like. You may not have all these options, and that's one of the biggest problems with communications, especially if you're working with the guys over the phone. We can't see these options. We don't know what options you need, and it's very difficult to try and troubleshoot communications over the phone. But if you bought a converter, so it goes from an RS-232 to a USB, that should, or a lot of them, come with either a disk for the install or it's actually loaded onto when you plug it in, it automatically does it. But what you need to do is you need a COM port. That's what you need. You need a COM port. Whether that's a USB drive that's being converted to a COM port is fine. You just need to know that that's the deal and know which USB has been converted. So in my case, my communications port is COM number 1. If I go into the properties here and go to the port settings, there we have our baud rate, our data bits, parity, stop bits, and flow control. If I go back over to the NC editor, we have the COM port, the baud rate, parity, data bits, stop bits, discard null, and then the flow control right there. And then right here you have your communication protocols. So this is going to give you delays in your characters or delays with your line delays. This is going to be kind of a drip feed. So you're going to slow down how fast you're shooting this code out to the machine and be able to bring it in. Like I said, if you are still using an RS-232, get in touch with me. Let me just talk to you about this ShopLink Flash and give you a chance to look at it, or at least give you the information to talk to the guy who makes them. This isn't fun to set up, and I can't find anyone that really has a complaint about these shop links. You set it up once, and then you have access to being able to take a USB wherever you want. The bigger part of it is there's no limitations on the USB. So sometimes you run into, some guys pay to get a floppy drive converted to a USB on their machine. If you do that, the USB that you get is going to be formatted to be the same size as the floppy drive. So you're not gaining any space out of it. The ShopLink will take care of that, and it'll drip feed for you. So definitely something, if you are interested, let me know. Otherwise, that's pretty much all I got for today. Close that out. Let me stop.